All right, preview number 2, getting us ready for our test coming up here. So, all right, here's our situation. Mr. Foss gives half the team a new replenishing energy drink, Husky Aid, and compares their performance to the other half of the team that received no drink at all. What is the group that is giving the Husky Aid called? Okay, so the question, because I see there's 2 issues I'm going to have to take up here. A, is it the control or treated group, and then B, is it an experiment or is it a survey? Or is it an observational study? So let's figure out the second part first. Experiment, observational study, or survey with what we're doing? Experiment. Why? Because we're not just observing, we're visibly giving, we're visibly doing something to half the team. So we know it's an experiment. So that wipes those 2 guys out. So now the question becomes, is the Husky Aid group the control group or the treated group? Which group's having the change done to it? Right, this is going to be our treated group because the group that got no drink, we didn't change anything, would be our control group. The group that got the new thing, this group, would be my treated group. So again, with this unit, there's a lot of mental problem solving going on. Not a lot of work to do, so again, make sure you put in the time. All right. A study that watches 2 groups that are different to see how they perform without manipulation is called what? I think I heard it. An observational study, because again, watches without manipulation. I'm not changing anything, I'm just watching them to see what they do and why they do what they do. But again, and it mentions here a study. So again, we wouldn't want to go to biased, unbiased, because that's just part of an experiment, which this isn't even one of those. Now I can get into a little bit of math. 2 letters are selected at random from the word mathematics. What is the probability of selecting 2 M's? First question. How many M's are in mathematics? Okay, so there's 2 M's, okay. How many letters totals in the word mathematics? 11. Because again, whenever we're doing probability, we need to know our number of successes. We need to know the total number of possibilities. So let's think about this for a second. So let's say I took all the words from mathematics, I cut them up, put them in a hat. So I draw out the first one. What's my chances of when I draw that first letter out that I get an M? Successes over total. 2 over 11, because there's 2 M's and there's 11 letters in the box, in the hat, whatever it happens to be. However, then I've got that M in my hand that I've already selected. When I go to dive back in, how many M's are still in there? 1. And how many letters are left in my hat or my box? 10. So I go ahead, I multiply across, and then reduce my fraction down. And I'm looking over right now going, I flipped my thing on that one. As my preview, we should be at B. Silly, silly man. So I will have to make note, or if somebody wants to grab a marker, they can get that fixed. But I will put it there for now. Number 4. A die is rolled. Find the probability of getting a multiple of 3. What are the multiples of 3 on a die? 3 and 6. So again, when we're doing probability, successes, the 3 or the 6, over the total number of options. 6. Which reduces down to 1/3. So that's how that one runs. So you're like, okay. And again, if there's questions as we go, feel free. I'll stop and try to explain something better if we need to. So number 5. Okay, thank you. So Mr. Harty attends a dinner that has 4 appetizers, 3 dinners, and 3 desserts to choose from. How many different ways can Mr. H select an appetizer, a dinner, and a dessert? Simplest way, what could I do to those 3 numbers? Multiply them. Because when I get one of each, I have 4 choices on the first thing, 3 choices, 3 choices. Get my answer. Okay. Keep life simple. All right, talent show. Now this is going to get a little more interesting. Family has 3 girls and 4 boys. Find the probability of each of the following if they select 2 children at random to bring to a local talent show. These are the ones where I'm going to get into fractions on each of these, but I'm going to do separate things for each. So, when I'm looking at this, I have to pay attention to the fact that I'm going to have 2 girls. Now, out of my 2 girls, if I have, I don't know, Amber and Amy or Amy and Amber, same thing. So that would be a combination. So just within the girls, there's 3 of them. I'm going to pick 2. But that's just taking care of the girl portion of things. Then I got to look at my total, because remember, probability is always about the total. How many total children do we have to think of? 7. So my denominator would be 7 pick 2. Because if I just did 7 pick 2, there'd take nothing into consideration about boys and girls. It'd just be 7 kids, you're taking 2. Then it'd just be this. But when we get specific, we have to look at it that way. So when we're doing that, again, and since you'll be in here, you'll have access to the calculators. Again, it's math and over the probability. And again, since the order doesn't matter, it would be a combination. And we would just do that. For each of these and reduce the fraction.
How do you know if it's like the same?
If order matters or if it doesn't. So like if you're talking with you and a friend going somewhere, it doesn't matter if you put your name first or the friend's, it's the same 2 people.
It just depends on the question?
It depends question to question on if the order would make a difference or not. Like for instance, we've said before, if you're picking 3 people, one's the president, one's the vice president, one's the secretary. Those are different positions, the order would matter.
Oh, okay.
But like here, if it's just people in a group, the order's not going to matter, so that's
like
why.
Picking stuff out, then it would be the C or whatever?
Yep.
Okay.
We're just going to have general groups. These are all going to be combinations. So here with 2 boys, same exact idea, except now I have 4 boys to choose from, and I'm going to pick 2. But my denominator wouldn't change at all. So we'll clear that out. We got 4. I'm going to pick a couple. But again, always reduce your fractions down. Oops. But not the way I just did. That's better. Then comes the interesting one. I get to do the easy part. I'll do the denominator. What do I do if it's for 1 girl, 1 boy? It's going to be in 2 pieces up in the numerator. If I were just trying to pick 1 girl, what would it look like? 3 pick 1. And I'm just going to do the same thing for the boy, except now there's 4 to pick from. So I do each of those separately. Now, to me, when it's 3, pick 1, I don't need to put that in the calculator. Because basically what's going to happen, but I'll work it out anyway, if you do 3, pick 1, you're just going to get 3. So big guess here, that's going to end up being 4. So 3 times 4 is 12. We know 7 pick 2 is 21. And I know I did it right because the only 3 different possibilities there are for picking 2 would be 2 girls, 2 boys, or 1 of each. Notice all 3 of them add up to 1 whole, which is why I know my answer was, and I probably could have done the last one even without doing the work, to be perfectly honest. All right. 2 dice are rolled. The table and relative frequency histogram show the distribution of the absolute value of the difference in the numbers rolled. Use the graph to determine which outcome is most likely. What is the probability? We're given the graph. We're given the chart of what the numbers are coming from. The greatest probability in the graph is, look for the largest or the tallest bar and what fraction it represents. 5/18. Okay? I really wouldn't even need this. I'd just be able to look at these and look for the biggest fraction that way. What's the least likely outcome? In other words, between 0 and 5, which one's got the shortest bar? 5. It's just taking the probability and actually applying it to something. Because there's the least number of combinations where you're going to get a difference of 5. Thank you. 2 dice are rolled. Find the probability. Probability of even or a 4. What does or mean? Plus. So we do them separately. What's my probability when I roll a die of getting an even? Half, or if I don't reduce it right away, 3 out of 6. You're like, why aren't you reducing it? Well, when I'm going to have to add and possibly subtract here, having that common denominator is going to help me. What's my probability of getting a 4? Okay, 1/6. However, if you have overlap, if you have a number or a value that's in both of those groups, we have to take that out because we don't want to count it twice. So is there any such thing as an even number that's a 4? Because my even numbers were 2, 4, and 6, and that 4 repeats. So my repeater, the 4, that's even, needs to be taken back out. You're like, well, then these just wipe out. Yes. And now 3/6 is 1/2. So whenever I see that or in there, I have to think when I get to the end, is there a way these two things could combine to be something that repeats? And if it does, we subtract it. Only with or. Because ands we're going to be multiplying.
Right.
Or in this case, you're like, probability of 4, 6. What's that mean? That comma is another way of saying something like then. We're still going to multiply. The only time we've got to add is when it says or. So what's my probability of getting a 4? 1 out of 6. What's my probability of getting a 6? 1 out of 6. So my probability of rolling 2 dice, getting a 4, and then getting a 6 is 1 out of 36. Again, it's all about the words in the middle. All right, let's see what else we got here. Art. The letters A are in here written on 3 different pieces of paper. The pieces of paper are then put in a bag and mixed up. Logan picks each letter without looking and places them side by side. What's the probability that the letters spell art? Okay, remember, successes over the total. To get the letters ART in that order, there's only one way you can do that, and that's if you get art. So I know the numerator is going to be 1. How many different ways can I mix up the letters ART, not necessarily to get words, but just rearrange them? Well, let's think about it with blanks, because that seems to be the way that clicks the best. So if I got the 3 letters in a bag, How many do I have to pick from the first time I pull a letter out? 3. Okay, but now I have the A out of the bag. It's in my hand. So when I go back to reach in, how many letters are left? 2. Then when I pull out the R, there's only 1. So I have a 1 out of 6 chance. Now I wouldn't suggest doing this, but I could just write down, since it's a shorter thing, every possible combination that I could run into with these. But do I really want to go through and do all that? No, I don't want to go through all that. So that's my simplest way to be able to do that. So again, just be cautious. Just use a little common sense. It doesn't have to be something fancy every time. All right, age. 24 students in Miss Mason's 3rd grade class, all born on different days. There's a shocker. 11 students are boys. In the morning, the classroom is empty. All sorts of weird information going on here. 1 student arrives, followed by another. What is the probability that when the first 2 students arrive, one is a boy and the other is a girl? Okay. Got my total number of students. 11 are boys. Doesn't tell me how many girls there are. How many are there? 13. Because again, I can take the information they have given me. There's 24 total. There's 11 boys. Whatever the difference is, has to be my number of girls. So when the first 2 students arrive, one is a boy, the other is a girl. We have to kind of combo this again. So to get my boy, fraction this up. "24 students total. I'm picking 2. Now I do it each part. One is a boy. I have 11 boys. Pick 1. For the girl, I have 13 girls. Pick 1. And again, these should always add up. The left side should add up to the bottom, right side should add up to the bottom. And again, when it's pick 1, that would just be 11 and 13. Now the 24, 2, you may have to jump in here. And I don't believe that's going to reduce, but we're going to check. Nope. 143 out of 276. All right. So let's see here. 12. Michelle, Brooke, Nicole, and Paul are candidates for the debate team. Their coach is going to choose a team of 2 to lead the group. Everyone's likely to get a position. Show the possible teams below. Okay, we've done this before. So I could pair Michelle with Brooke, Nicole, or Paula. And again, Michelle and Brooke, Brooke and Michelle, same team. So I look and I go, okay. Then I got Brooke. I already matched her with Michelle. Still could do Nicole and Paula. And then when I get to the end, Nicole, I've already got her with Brooke. I already got her with Michelle. I can still have her with Paula. So there are 6 possibilities. So I look and I go, okay. Probability that Brooke and Nicole are the team. How many of the combinations have Brooke and Nicole? Okay. Only one of those combinations have both Brooke and Nicole on the team. This one. All the rest of them are going to be different. Here's my good one of the day. The team is made up of the 2 men. 0. There aren't any men. Somebody needs to do something about that. No, just kidding. So again, read carefully to kind of see how those are working.
I know there's 6.
1, 2, 3, 4, 5, 6.
Okay, I didn't know if we were counting.
Yeah, just those 6 are the possibilities. Flip a coin 3 times. What's the likelihood I flip tails all 3 times? They're 3 separate events. What's my chances of getting tails or heads anytime I flip a coin? Half. So the first time it's a half. The second time I do it, it's a half. The third time I do it, it's a half. So 1 out of 8 times I will get 3 tails. Unless I wanted to write out, kind of make a chart like this, I could do it that way too, but yeah, it takes more time. All right. If the probability of an event happening is 2 of 9, remember, probability. That's going to be the outcome that we want. So we could have, so happening, total outcomes. Because again, it says it started with probability, and that's how probability works. What are the odds of the event not happening? If it happens 2 out of 9, how many times does it not happen? 7. It's 9 minus 2 equals 7. Excellent. Because when we're doing odds of not happening, it's the not happening over, or colon, you could put 7 over 2. 2, because again, these two add up to the total outcomes when it's odds. But what they want the odds of always goes first. All right. 15. In our class, well, not this specific one, we have 20 juniors and 4 sophomores. There are 13 junior males and 3 sophomore females. Represent the data in a tree diagram. Now, that doesn't mean you need like 24 little branches. You have juniors, you have sophomores. I like to put the numbers next to them. And then within each of those groups, you have males and females. And it tells me there's 13 junior males. It tells me there's 3 sophomore females. Notice not every one of my letters has numbers right now. How would I fill in, or what are the values that are going to be filled in on those other 2 variables, my junior females and my sophomore males? Sophomore males would be 1, because there's 4 total. I already took care of 3. What about my junior females? 7. And I also notice here there's 24 total students, if that comes in handy for me here in a minute. I'm just using the tree diagram to get me some info. And I see lots of ors. Bless you. So what is my probability of being a junior? $20 out of 24. Again, we'll just leave it for right now because we're going to have to do some adding here. What's my probability of being a female? 10 out of 24. But then, what is my probability of being a junior female? 7 out of 24. We got to get rid of the overlap. 30 minus 7 is 23 out of 24. The odds are pretty good. And that's what we're going to do for all of these. We already know the junior one. So I'll just go ahead, I'll get that one in, put in on both of these. What's my probability of being just a male in general? $14. How many male juniors do I have? 13. So I've got to get the overlap out. 34 minus 13 be, oops, my 7's not showing up real well there. Be 7/8. And then the last one, juniors, okay. How many sophomores do we have? 4. And if you really stop to think about this for a minute, you're like, oh, duh. You can't be a junior and a sophomore at the same time. There's no overlap. It's 1 because the whole class is juniors and sophomores. You're going to get one or the other when you're going to do this. So again, keep it simple. We're skipping 16 because, again, we whacked the Venn diagrams to get odds. So 16, give the old X out. We'll get to start rolling on these last groups here. All right, here's our chart. We got all our totals done already, so we don't have to do it on our own. Probability of finding someone with a 3.0 or greater GPA. How many of those people total are there? 50. How many total people are in our chart? 106. And reduce the fraction. Now, one little word in the next two is going to change things.
Wait.
Okay.
For the first one, why would you add 4.0? But it says 3.0 or greater, so 4.0 would be greater.
Right, and I don't like the way this is run. In retrospect, yeah, it's just a label for the column. In retrospect, I should have just put 3.0 and 2.0 because I like the way you're thinking on that. Because, yeah, what I meant to do was just that you were working with this column. But if that were like a quiz and you did that with that reasoning, I wouldn't mark it wrong because it's absolutely reasonable. So when we get to 18 and 19, we have the word given. But again, I'm just thinking of the column specifically that I have here. Given it's a 2.0 GPA, so we're only working right here. So given a 2.0 GPA, there's 30 of those total. How many are female? 13 out of 30. So that's what we're looking for. That word given just means we're going to take whatever's after it and narrow things down just to where that's at. So given it's a male, there'd be 47 total males. How many of them have a 3.0 plus GPA? 22. And I'm set.
Wait, why is it?
Because given male, I look for the total number of males is what I'm going to be looking out of. The given number is going to be my denominator.
Oh, okay.
Yeah, that's what I've got to watch for on those. All right, 20. Marjorie, I can't even say that because never mind, is playing a game that uses the spinner shown. What's the probability that she spins the number 6 given that she spins a number greater than 2? Spins a number greater than 2, there's 4 options. How many chances does she have to get 6? 1. So again, whatever's after given is my denominator. What's right before it? A chance of getting 6. There's 1 chance of getting 6, and that's all I need. I'm done. Again, keep it simple, keep it simple. All right, 21. In a class of 25 students, how many committees of 3 students can be chosen? Notice, doesn't have specific jobs. General. 25 for one of the spots. And once I picked one, now there's only 24 left possible people to pick from, and then 23. And just multiply them together. Just use your fundamental counting principle. Don't try to get fancy. You could attempt to get fancy and use combinations, but fundamental counting principle, when possible, really makes life much simpler. Oh, then back to odds. Odds of a student getting an A on the test are 7 to 3. Get an A, 7. Not an A, 3. Now we're going to put an application with this. here's my first question. So if 7 got an A, 3 didn't, how many total tests were taken? Okay, 10 total. So the question now is, if he takes 20, how many do you expect him to get an A on? Well,
Don't you just double it?
yes, because if he got an A on 7 out of a total of 10, and I want to know if he takes 20, how many A's did he get? I agree. You're just doubling the number of A's that he got before. So we just use a little bit of fractional ratio type math here to get that final answer, but I got to apply a little bit.
Wait, why is it 10 not 3?
Because remember, with odds, it's telling me successes and failures, not successes in total. So it just means if this is my times I got an A, this is the times I didn't, that would tell me he's taken 10 total tests so far.
Oh,
Okay? But you were right on your initial where it's just going to be doubled in that case anyway, since 20 tests is twice as many as 10. And the last thing, experimental and theoretical probability. Now up here, this is my experimental. I actually spun a spinner 50 times to get all of these. So again, these values represent the number of times I got each of these numbers when I spun the spinner. They'll add up to 50. So when it asked me to find both theoretical and experimental for these, the experimental means use the chart. So for instance, my probability of getting 1, 3, 5, or 8 experimentally would mean I'd add up the number of times that I got a 1, number of times I got a 3, the number of times I got a 5, and the number of times I got an 8 out of 50. So 11, 18, 26 out of 50, but that reduces to 13 out of 25. And I normally will just do all of one column first, because then I can go back and think the other way. An odd number greater than 3. Okay, let's think about this for a minute. Odd number greater than 3. What would that include?
5 and 6.
Yeah, greater than 3 gets me this group, and odds in that group get me 5 and 7. So 8 and 9 is 17 out of 50. Doesn't reduce anymore. So again, everything's coming from the chart. 25, not 6 or 8. Now the easier way to probably do this, instead of saying it's 1, 2, 3, 4, 5, and 7, and adding all those up, would be to take 50 minus 14, 36. I could add those all up, I'd get 36 as well. And get my values. Theoretically, what should happen, we're like, that's 4 of the possibilities out of 8. So theoretically, that should happen about half the time. That's pretty close. Exactly half the time here would be 12 and a half, which you couldn't get. So that's pretty close to theoretical. Odd number greater than 3, 5 and 7. 2 choices out of 8 possible options. That one's a little higher than it should be. But again, that's why it's experimental. Not 6 or 8 successes. There's 6 of them out of 8 total possibilities. And I'm set. Basically, that covers everything we've been doing here for this last couple of weeks. Kind of playing with these in different ways. So what I'll do